Right. Now, suppose we have a problem like this. In this case, we could go about this in much the same way as before. We could do it this way. We could subtract. I'm going to put it like this. And again, we're going through PEMDAS backwards. We can sort of solve for this. So we can treat this like, because it contains a variable, this whole piece is a variable. Because if this is unknown, then 2 times this plus 3 is also unknown. So we can kind of think of this as sort of one giant variable. And so what this becomes is a 7 minus 11 times this unknown. So we're going to treat this like a 2 operator problem. We've got a positive 7 we're going to cancel before we try to cancel the multiplication by 11. Or what it's going to turn out to is multiplication by negative 11. Now divide both sides by negative 11. Because positive divided by negative is negative 1. Now this might seem kind of strange because it looks like we're subtracting an 11. You could think of it that way. The thing that's going to stand out, this 11 is multiplied to the parenthesis. So that means we need to eliminate anything else that's a constant number that's floating out here. And so that's what we're doing here. Another way of imagining this is you could think of it as negative 11 times 2z plus 3 plus 7 equals 18. You could think of it like that. We're treating this as, for now, one giant variable. And so when we do our cancellation, this is a multiplication by negative 11 and a plus 7. We get rid of the plus or minus first, then we'll deal with the multiplication by negative 11. So the reason I'm canceling the 7 like this is I'm approaching it this way. Another way of putting it, since this is multiplied, we want to try to do this last as much as we can until we get into here. And so floating constants, let's get rid of those first before we try to do anything with that times. So that's why we cancel the 7 and then we divide by the negative 11. All right, we can drop the parentheses. Proceed as before. Subtract 3, subtract 3. 2z minus 4. Divide by 2. Z is minus 2. And that's it. So it's not that. That's one way of doing it. Now, there's another way that might be a little simpler because it was kind of confusing. Like, wait a minute. Do we get rid of this first or this first? And we're supposed to think, well, this is multiplied to that. This is just floating. So we get rid of the floating thing. Then we deal with the multiple. There's another way you can do this. And that is distribute. If that other way works, go with that. But we can also distribute. Send minus 11 to each term on the inside. So what we'll get, negative 11 times 2 is negative 22. So minus 22c. So negative 11 times 2 minus 22. And then negative 11 times 3. We don't want to forget that. Got to get that too. That's minus 33. And the distribution only goes to what's on the inside here. It won't go to this here, and it won't go to this either. Only what's inside the parentheses. Now we can combine some like terms. Now this is a type z because it has a variable z. These are type constants. So let's set these next to each other so they'll combine. 7 subtract 33, well, what's that going to be? Negative 26. All right. Now we've got a 2 operator problem. Negative 22 times z, and then we've got this negative 26. We're going to get rid of minus 26 first. We deal with the multiplication last. Add 26 to both sides. That'll cancel. Minus 22z equals, it's going to be 40. And then lastly, we'll divide both sides by negative 22. And we'll get z is negative 2. And that's it. So again, there's 2 ways you can approach this. And it might be easier to do the distribution way. It might be easier to cancel this, cancel that, and then work with what's on the inside. Whichever method works best, go with that. But that's it. Any questions? Let me know.